All right, so what you're going to notice is the name of this, right? It's Pythagorean identity. Way back in geometry, you talked about and studied the Pythagorean theorem, probably in 8th grade also. All right, so what is the Pythagorean theorem? That's right. Whoa.
Where's that on the wall?
Right up there, the back wall. Okay, so what does that have to do with trigonometry? What does that have to do with sine and cosine? All right, so let me kind of go through this real quick. But imagine, remember we talked about sine and cosine and circles and stuff last time, right? Let's do this. Let's say there's a random point somewhere on the circle. The coordinates of this, x and y, right? Okay. X is the distance from here to there. So this is x. What's this? That's y. On the unit circle, remember we talked about the unit circle. Unit circle has a radius of 1 everywhere around. And that means no matter where you draw from the center of the circle to the edge of the circle, the radius is 1, right? So if we set up the Pythagorean theorem here, we would say like this. You don't have to write this down, but it would look like that. Now, what's 1 squared? 1. So we end up with this. But we also found something out last class period. And it was that every x coordinate on here is equal to the cosine of the angle, right? Theta. And then every y coordinate is equal to the sine of the angle. So here's what we could do. We could say, instead of writing x, we could say cosine squared. This is weird, but this is how you write cosine squared, okay? You write it in there. So that way it's not confused. You don't think theta is squared. If you write the squared out here, it looks like this is squared. Everybody get what I mean? Okay, it's kind of funky. And then every y coordinate is equal to the sine. So then we end up with this thing called the Pythagorean identity, which is also back there on the wall. It's written in a different order. It's sine plus cosine, but it's in the purple and green brick back there. See it? Okay, there's actually lots of Pythagorean identities. There's usually 3 that we look at. Only 2 of them are on that brick. There is one more. But this is what we're using today. So if you're writing anything down, it would be this, right? This is the Pythagorean identity. And you're going to have to use this like a formula today when we do our work. All right? Now, before we begin, a question, I want to review one thing. That's why I have the grid up there on the smartboard. You see it up there, the little XY axis. Let's talk about quadrants, okay? What quadrant is this? This quadrant 1, and we use Roman numerals. What quadrant is this? And 4. It goes that way, right? In quadrant 1, both coordinates are positive. In quadrant 2, negative, positive. In quadrant 3, they're both negative. Remember, when we're talking about x and y, right? It's x and y. And then here, positive, negative. Nice to review that. So this will be like a little footnote today. Whew. Deal? Let's get into a question, all right? Here we go. All right, it says the angle, theta 1, is located in quadrant 4. And the sine of theta, I'm not going to say 1, is equal to negative 24 over 25. First of all, it's in quadrant 4. So let's look here. What we're talking about is quadrant 4, where all of the x's are and all the y's are negative. Okay. Now, another way to think of that is instead of x and y, we think cosine and sine in alphabetical order. That's the way I taught you to remember it, right? So the cosine of an angle would be positive here. The sine will be negative. Let's go back to the question. If the sine is this, what is the cosine? Here we go. Here's our equation. We have cosine squared plus sine squared equals what number? 1. What do we know already? We know the sine is this. So this becomes squared. What we're trying to figure out is what is the cosine. Okay, so here we go. So you can use your brain, you can use a calculator. I want somebody to tell me in fraction form what this is. One way to do it in the fraction is to just square the top and square the bottom. So let's do that. Help me out. I can do the bottom. You gonna beat me? Okay, it's waiting. Now remember, anytime you square a number, it is, which means when you square a negative number, it becomes positive. Please don't forget that, right? So a lot of people will just type negative 24 over 25 and then square, and the calculator will mistakenly print out a negative number. So make sure you don't let that happen. All right, now over here, here's what I want you to do. Once you get your answer for this, I want you to change this 1 into a 625 over 625. This will make our addition and subtraction much easier when we solve the problem. So whatever I get for a denominator here, I'm going to put over here in the place of the 1. It's kind of funky, but it'll pay off. All right. Now this is equal to, or sorry, we still have the cosine squared over here. So let me just screenshot our work, and then I'm going to move it over to this. Let's keep going. I need to solve for cosine, so I have to do this in 2 steps. First thing is, let's move this way. And by move, I mean subtract. Awesome. When I subtract this, I just subtract the numerator. That means the top of the fraction, because I have already set up the 625 as a common denominator. That's why I had you change it. All right, so what we're really doing here is we're doing 625 minus 576. 49, yep, 49 over 625. And now this is the cosine squared. Remember, our goal is to solve for cosine. So let's do the square root, right? When you do the square root of a fraction, you do the square root of the top and the square root of the bottom. And it just so happens 49 is square root 7. And the bottom is 25. Whew. Now, one last thing, and it's the most important thing, because you could do all of this right and mess this up if you don't get the quadrant right. What quadrant were we in? 4. We're doing the cosine, right? Here's the thing about square roots. When you take a square root, there's actually 2 answers. There is a positive answer and a negative answer. Because what you're doing is finding the number that if you squared it, you'd end up with 49. So the answer could be negative, right? But since we're in quadrant 4 and we're finding the cosine, quadrant 4, cosine, it should be positive. So that's why it might be useful to write that down. Okay. So back to our question. Is it positive or negative? Which one? Positive. So our answer is just positive 7/25. Okay. Now, it won't always be that we can simplify the square root of this number on the top. So let me just do this real quick. Let's pretend we got an answer like this. Let's say it wasn't 49. Let's say it was like 51. You can't take the square root of 51. So your answer will end up being something like that, because you can still take the square root of 625. So if you can't take the square root of the number underneath here, just leave it alone. Everybody understand that part? Okay, so that's why when you look here, when I typed in the answer, there was this available for you. Okay. All right. Let's do one more. Here you go. This time it's in quadrant 2. And then it says the cosine is equal to this. Every one of these questions will be the same as far as I know. All right, let me just double check. Right? They all look pretty much the same. So same process over and over again using the Pythagorean identity. So here we go. We have cosine. Let's copy this thing over. That means we're going to try to find the sine. Here we go. We know cosine squared plus sine squared equals 1, correct? So the first thing to do is substitute. We have negative 22 over 29, but we have to square that thing. I'm going to go fast here. Somebody help me square these two numbers, 22 and 29. Forget about the negative. What'd you get?
554 over 841.
Oh, my. 554. Whoa. 484 is right, yeah. And then what? 841 plus sine squared. And remember our little step here, we're going to change 1 so that it looks like the other fraction, so that then we can subtract, right? Okay. So after all the explanation or whatever, these problems really aren't that long. They're really not. But if I just started into it, you're like, well, where did that come from? All right. So anyway, let's subtract now, because we got to move this whole thing over there. Okay. So we're just subtracting the top part, right? We're leaving the bottom alone. What'd you get one more time for me? 357. Thanks for your help. Now it's time to take the square root. Going fast, going fast. So square root of the top. Let's see if we can simplify it. You can't. You got to leave it alone. How about the bottom? What was the bottom? Well, that was 29. It came from right there, right? You can always find that one. See, 29 is just up here. It's the number we squared. So our answer will be this, or it'll be the negative version. Which one? What quadrant is it in? Quadrant 2. Quadrant 2, and we're looking for the sine. Quadrant 2. All right, this is cosine. This is sine. So the sine is positive. Awesome. So we're going to go with positive messy fraction, whatever it was, right? The positive version. So here we go. Hit this first. This will be helpful. And then on the top, hit that thing. It was 357.
Mm-hmm.
Wow. 29. All right. Bingo. All right. Don't forget your answers can be negative, right? We just had 2 positive ones. Let's try this one out.